Good time of the day, everyone. This is 11th of February 2025, and we're here to present you one of the new series of Epic members' new product release. And today we have several exciting speakers that will show us the new products of the members of Epic. Let me remind you that Epic is the European Photonic Industry Consortium, the largest photonics association in the world, comprising more than 800 corporate members in Europe and also all around the world. And today we have an exciting agenda. We'll have 5 speakers from Epic members that will show us their new products. We'll start with Łukasz Sytniewski. We'll start with Łukasz Sytniewski from Noctiluca, and follow up by David Cardador Maza from Mapsi Photonics. We'll then hear from Cristina Barbosa from HBK FiberSensing and Kristian from SHUTE Sensing Solutions. Last but not least, we'll hear from Patrick O'Donoghue from SILENTSYS. And with no further delay, I'd like to invite the first speaker of our session to present their NCAEIL4 product. Is Łukasz Sytniewski. Please, whenever you're ready. You can go ahead and start your presentation, Łukasz.
Yeah, can we hear each other?
Yeah, that's all good. The floor is yours.
Great. Good afternoon, everyone. First of all, thank you for the invitation and giving me the opportunity to present newest product development at Noctiluca, which is NCAEIL4 material. However, beforehand, let me introduce Noctiluca and say a few words about who we are and what we do. We are a deep tech company located in Poland, focused on designing and producing materials for the product of the future. Currently, we operate in the main 3 areas. First pillar of our activity, which was also a starting point of Noctiluca, is own research and development strongly focused on the TADF emitters for the OLED applications. After some time, and as a result of many interactions with the industry, we realized that we can support our customers acting as a chemical contract research organization, providing solutions in the other fields of than TADF emitters. That is how the second pillar of our activity was established. Knowing that for the best performance of OLEDs, high quality materials are a must, we decided to set up another pillar of our operation, which is the custom synthesis supported by a sublimation service. With this, we are able to lead any synthesis process of IP, free organic materials, in the field of broadly understood optoelectronics. We are located in the heart of Europe, Poland, but our team members and numbers of our partners, both from the industry and academia, with whom we establish a daily collaboration, are located worldwide. Few facts in our history. At the beginning of our road, in 2019, when Noctiluca was launched, we were focused only on the TADF design. This period in our history can call as a building up the technological platform. We were able to design and synthesize our emitters in-house, but unable to fabricate and characterize the entire device. That is why we launched our research lab in Korea. Later, lots of effort was made on building up a commercial pipeline. Number of various projects has started, and we evolved from being a designer of emitters to the producer of the materials for the products of the future. During that time, we also had our debut on the New Connect stock exchange board, similar Polish alternative to the US NASDAQ, and we've opened a new lab facility into it. Currently, As a result of intensive R&D work and various cooperations, we have reached industrial trials readiness. At the end of the last year, Noctiluca has moved into main board of Warsaw Stock Exchange. I hope now you have at least a feeling who we are and what we do. Thus, please let me introduce our newest product, NCIL4, which we strongly believe might be a solution to the lifetime problems in blue OLED devices. One of the hottest topics in the OLED world is a new TADF, blue TADF emitter, which is supposed to improve device performance and extend the lifetime. Also, Noctiluca, through own in-house research, intensively is focusing on this subject. However, within the time, our approach to the rays of blue has evolved. The problem with the lifetime of blue-based OLEDs is right here, right now, and needs to be somehow solved. Looking at the simple structure of OLED diode, one can see that particular emitter is only one layer of many other layers within the entire stack. The other layers responsible for carrier electrons and holes also has a great importance in the entire structure. In the end, performance of these materials has a great contribution to the overall device performance, resulting in example in color saturation, brightness, and might have a great impact on the lifetime as well. That is why Noctiluca is aiming to be a designer and producer for the entire emissive layer MB. Our NCIL4 material, developed as a solution for real industrial need, is our proposal for electron injection layer material. After many internal tests, we found benefits of NCIL4 in both performance in the device and as a material alone. We've compared our material to the common and well-known EIL material used in OLEDs, which is LIQ. Devices based on our solution show significantly higher longer lifetime in comparison to LIQ-based reference. We have also observed beneficial reduction on a device working voltage. All that was achieved without compromising any other parameters of diode, such as turn-on voltage or influence on electroluminescence spectrum. Our material can be supplied as a high-purity sublimed grade, which is also very important. On the top of that, NCIL4 dissolves well in polar solvents, what we think might be an interesting feature for the potential use in the inkjet printing applications. As we don't have too much time to present all the data, let me focus on the most important aspect, which is a lifetime improvement. For our test, we've used a bottom-emitting architecture and utilized the first-generation blue emitter. It has to be mentioned here as well that our research results are in line with the research at one of our industrial partners. The simple exchange of LIQ for NCIL4 as an electron injection layer results not in several or dozen percentage improvement, but in 5-fold lifetime increase. We thought, can we do better than that? We decided to try to adopt electron transport layer with our solution while keeping NCIL4 also as an electron injection layer. The results of this experiment lead us even for further lifetime improvement. We've reached, in comparison to LIQ-based device, improvement in lifetime by 15 times. These both sets of experiments proved that NCIL4 can be used either as an electron injection material alone or as a combination of electron injection layer and dopant to the ETL layer. This is our proposal and contribution to the rays of blue from the perspective other than emitters, on which, of course, further research at Noctiluca is ongoing. This year, we want to focus on finding the conditions that our material will perform best. We strongly believe this will lead us to increase the number of EL materials in our portfolio very soon. Of course, you can find us via social media or through our web, and I'll be more than happy to assist in providing further details on our solution. Thank you for your attention and time.
Thank you, Łukasz. Great presentation. Very exciting material you have there.
Thank you.
And let me remind everyone that today after each presentation we have a couple of minutes for questions and answers. So please, if you have a question in mind, don't hesitate to push the raise hand button at the bottom of your screen, and we'll pass you the word. And I'll start with my own question for Łukasz briefly. So you said that this material can radically improve the blue LEDs. Would it also work for UV LEDs?
Well, currently we've been testing only with a blue color because we are part of this race for blue. But we currently proceeding with trying with different colors like red, yellow, and green, which is on ahead. The UV was not in plan yet. However, it's if there'll be interest, who knows?
Okay. No data for the red and green so far?
So far, no. There are relatively fresh results for blue, and we've been very excited seeing the first set of results, and we hardly believe in that. So we decided to repeat the results, and repeating the results proved again the performance of NCAL4. As I mentioned, this year we would like to strongly focus on finding the boundary conditions in which the material will work best. So probably quite soon we'll be able to say something more about in which specific condition the material works that excellent.
Okay. Yeah, but even if it's only blue, that indeed looks very impressive, the results. So congratulations with that.
Thank you.
Any more questions for Łukasz? Well, if not, I guess it was very clear actually what you offer. So good luck with commercializing this, and looking forward.
Thank you. And if you have any questions, I encourage you to send us an email, and we'll be happy to assist in further explanation. Thank you.
Yes. Okay. Yeah. Thank you, Łukasz. And with this, I'd like to invite the second speaker of the session today, David Cardador Maza, who is the CEO and co-founder of Mapsi Photonics. And David will talk about all silicon infrared windows for photodetectors. Welcome, David.
Hello, and thank you for the invitation.
You're welcome.
I think, can you see it?
Yeah, just make it full screen, and the floor is yours.
Okay. So yeah, as Ivan said, I am David, one of the founders of Mapsi Photonics and the CEO of the company. We created it in 2021 with the aim of designing and manufacturing infrared filters and windows for infrared applications. Our focus is in industrial applications as well. Among many applications that we have, we are targeting the process monitoring, gas monitoring, and surveillance of industrial plants. We do it with a special technology, disruptive and patented technology, that basically what we do is we have simplified the way how filters and windows are done. Instead of adding layers over substrate, germanium, silicon, one over another, what we have done is to simplify it, as I was saying, and we only drill the substrate. In our case, it's just silicon. And by controlling the shape of the holes that we drill and the length, we are able to increase the resolution if we are talking about filters, especially when we are going to the long infrared region. And also we have a high quality and mechanical characteristics of our filters and windows, because we are only using silicon, and it melts, for example, only in 1100 degrees. Also, we save we save costs and energy because we are using electrochemical process, and we avoid the intensive use of electricity, for example, as it is done in conventional technology. Also, we avoid the use of critical materials like germanium that are restricted geographically. As I was saying, the products that Mapsi we market are bandpass filters in the whole infrared region, from the middle wave infrared to the long wave infrared. We have narrow bandpass filters, broad bandpass filters, windows. Also in here, we are going from 1 micron to 14 microns, and neutral density filters. And regarding the new product that we are today presenting, we are presenting the macroporous silicon windows that go from 3 to 5, that are specially thought to be used for the photodetectors. And we can see that our new product, those windows in the 3.5 window, have high transmittance, around 95% in average. As I was saying, they are highly robust because we are only using silicon. They can be cleaned with water, alcohol, dry wipes. It doesn't matter. They don't change their spectrum. And they are also highly robust to high temperatures and corrosion, and that made them very useful, for example, for pyrometers and thermal cameras that are used in melting steel processes, for example. And what is also very, very interesting from our windows is that we have low angular dependency. So if we fix a specific wavelength, the shift that we experience, it's less than the 3%. But if we go to the competence, they are having a 15% of this in this shift. So we reduce 5 times the expected shift regarding the competence. And also we reduce less than 3 times the transmission variation in the whole range. That means if you do an integer in the whole range, we have less than 1% of transmission variation, while the competence is a little bit higher than 3%. Here we have shown the comparison with low cost and high cost competence, and we can see we have higher transmittance than the low cost. And also what is really interesting is that we have a really flat optical response of our windows, and that makes them very suitable for those applications that you need calibration. So you don't have any problem with our windows if you have an angular regarding the light incident. And also it is interesting because it's quite homogeneous, and you don't experience this shift, or you don't have to recalibrate your camera. And so to sum up, as I was saying, we have a highly robust mechanically, we have a high optical product that are really interesting for thermal cameras and pyrometers, also to point detectors used in non-dispersive infrared detection, gas sensing, and also for the focal plane arrays that are used inside the thermal cameras as a photo detectors. So this is all. Thank you very much.
Hello, David. Yeah, thanks very much. Very exciting product, very exciting developments you guys are doing at Mapsi. Yeah, once again, so everyone is welcome to ask questions, especially if you feel like there might be something, a touching point where you could speak with Mapsi. You're very welcome to raise it. And in the meantime, yeah, David, do you have maybe a few examples of already successful integration of your filters into some products?
Yeah, in the 3 ones that I said, in the FPAs was the first one that we made at the middle of 2024. and then some others in thermal cameras and in point detectors as well. Yeah, in the three of them.
Okay, then maybe something where what can the other members of Epic do for you? Meaning, would you need support with the integration?
It's interesting because that some OEMs that they are using this kind of windows, of course they can contact us, and depending on the customer, there are different characteristics. Some of them they work in vacuum, some others don't. So if we test them, it's interesting also to us to check and to test them in different environments.
Okay. Yeah, I see one interesting partner there could be for you, AMS Technologies. So Torsten, do you have a question? Just unmute yourself.
Yeah, sorry. We are very much interested in this technology as we have customers who are active in thermal cameras, for instance, for firefighting applications. So my question is in one direction, the robustness. You said a few words already. So is there any issue if you use it in a fire regarding dust and smoke and stuff like that? And where are your windows price-wise compared to germanium, for instance?
Okay. Yeah, we're certifying our windows right now, so we're in the process of it. What we have done is just internal tests. So and they passed them, but we are now certifying them. So I cannot tell you specifically this one with the smoke. But and comparing to the Germanium windows, sorry. Well, let's say that we are a little bit low cost than they are.
Okay, right.
Yeah, especially the ones that are covered with the DLC and so the comparison we are quite lower than them. Yeah.
So we should contact each other after the meeting here. This is really of interest for us.
So thank you, Torsten. Yeah, you can. I think that they will share the email, hopefully, because I forgot in the presentation. But anyways, they will give them to you, yours. So I will contact you back. Yeah, thank you.
Thank you.
Okay, that's the spirit, guys. Thanks, Torsten, for your question. And so looking forward also to put you guys in contact. All right, so with this, we thank David again. And let me introduce the third speaker, who is Cristina Barbosa, product manager at HBK FiberSensing. And Cristina will talk about bringing light to measurements, high sensitivity FBG accelerometers for civil structures. Welcome, Cristina.
Thank you, Ivan. Hello, everyone. Thank you for your time here. You can see my screen already, right? Yes, screen sharing. So my name is Cristina. I am product manager for the optical business. And in similarity to my fellow presenters, I will first start with telling you who HBK and HBK FiberSensing is, and then we go into the product that we are presenting here today. So HBK FiberSensing was created first as a spin-off, only FiberSensing, more than 20 years ago. And a company that produces and develops fiber Bragg rating-based measurement systems. So for test, for measurement, and for monitoring. So FiberSensing was then acquired after 10 years of existence on its own. It was acquired by HBM, so a big company based in Germany that already had many years also of existence and traditionally known for their conventional strain gauges, so resistive strain gauges. They were already exploring some solutions based on fiber Bragg rating, and they decided to acquire FiberSensing. It was a very good match at that time. Then the company grew, and in 2019, the HBM merged with Brüel & Kjær, which is another old European company from Denmark that produces mostly accelerometers and microphones, so more to the frequency domain of the measurements. And it made sense for the two companies to become one. And so that happened a few years ago. And this is how HBK FiberSensing appears in today's world. So we are located in Porto. This is where FiberSensing was created, and all of our development and production activities are done. But thankfully, we rely also on the global presence of HBK through their own offices around the globe, or through distributors as well. So it's also very good to have this local presence. So if you are not in Portugal, it's always good to have someone that talks your own language for the opportunities that may arise. So I think that this is a very good thing. So if we start with the product that I am here promoting today. So this is an accelerometer, so a sensor to measure vibration. It is called a high sensitivity accelerometer, so to get big insights out of very subtle, very small vibrations. This was the gap that we had on our portfolio that we tried to fill with this sensor. So this sensor is based on the New Light technology. New Light is a product line from FiberSensing, from HBK FiberSensing, that combines several technological aspects of the fiber on the coatings, on using femtosecond FPGs for ensuring longevity on our solutions, on our measurement solutions, and also compatibility throughout our full portfolio. The biggest innovation on this sensor is the high sensitivity that we managed to achieve. So we are using the fiber rag rating technology for measurement, so watching the fiber rag rating peak changing and measuring the wavelength variation. Here we are able to detect per G 1,300 picometer variation. So this is the sensitivity of the sensor, and that in combination with performing interrogators can allow us to make measurements as small as 10 micro G. So very interesting for very small measurements. This is true throughout its also frequency operating range. So we have the sensors designs for measuring plus minus 2G or plus minus 5G, and this throughout a frequency range or with the same sensitivity from almost 0 to 75 Hertz. So this ensuring a 10% flatness. But as you see on maybe it's a bit small, but as you see on the peak, it's possible to measure. So the resonance frequency stands at 240 Hertz, and we can measure up to 100, maybe with a slightly higher level, but also still under a very good result level. Then we are using two fiber rag ratings to ensure long-term stability and compensate for the effect of temperature on the fiber rag rating and on the sensor itself for a seamless operation between -20 and 80 degrees C. And also another interesting characteristic is that it uses dual fiber. So the fiber rag rating, as you might know, can be measured from both sides of the line of the fiber, and the fact that the sensor has the two lines allows for the assembly and connection with other sensors. Could be assembly in biaxial or triaxial configuration, could be combination with other sensors and other measurements based on the same fiber rag rating principle. So this is a very interesting sensor developed with the focus of applications in structural health monitoring, namely on vibration monitoring. So I would like to share with you where we use this type of sensor. So as mentioned in vibration monitoring, for example, using it for ambient vibration and for model analysis of bridges. So when you have big structures that are very stiff, you have very small frequencies on the vibration modes, and you have also very small amplitudes of this acceleration. That's why you need the high sensitivity to detect it under this ambient vibration. So it's also possible to perform tests with excitation on the bridge, but those are more difficult, and the ambient vibration is a very good way to access the structural health of the structure. Then it's also possible to use, for example, on the determination of tension on cables, so also with the purpose of structural monitoring. The tension on the cables is proportional to its vibration properties, so it's possible also to determine the tension on the cables. And another example would be using it on monitoring of wind turbines, so either onshore or offshore, where the optical technology is quite interesting because fiber doesn't corrode under the wet environment and salty environment, and also has other advantages here on this environment. So summing up, in terms of the characteristics of the sensor for these applications, so the first and biggest characteristic of it is its sensitivity. So the fact that we can measure detailed acceleration levels is very interesting for the ambient vibration and for the monitoring of these large stiff structures. The fact that it is temperature compensated, so this gives stability over time on the measurement and the possibility to measure very, very low frequencies as well. This is highly important as the fiber vibrating is quite sensitive to temperature as well. So it's always a thing that we have to consider whenever using fiber vibrating technology for this type of monitoring applications. The fact that it is fiber optic, there are other technologies, of course, for the same type of application. But when we are talking about long distances or long structures like you have on big bridges, the optical comes as a preferred choice because of this. The fact that the fiber has low attenuation means that we can address several sensors with the remote locations, in remote locations. Additionally, we can have several sensors in series. This is general for the systems based on fiber vibrating technology. And the fact that we can have several sensors makes the full solution cost effective. In particular, our offering is of course compatible with the other HBK offerings, and this means that we can deliver a fully structural health monitoring solution, not only the fiber optic accelerometer, but also combined with other sensors from the same technology, and moreover sensors and other equipments from other technologies that can seamlessly be integrated into full systems. So with this, I come to an end, and I would like to invite you to learn more on our website, where you can also find some documentation to download. And of course, I am available now or by email to answer to your questions.
Okay, Cristina, very exciting applications you show. Very nice product. Thank you for the presentation.
Thank you.
As always, is there any questions from the audience maybe? In the meantime, I'm wondering also, so you showed the example with the bridge. So what other kind of structures it can be used for? I mean, just also tall buildings and
yes, tall buildings,
engineering structures.
The wind turbine, so those type of structures, nuclear power plants, so structures, offshore platforms, so I'm remembering as I speak. So those type of big structures that have low frequencies, low vibration frequencies, and also where you need the small amplitude. So if it's not a structure that is highly excited, then you have these small accelerations and the sensor becomes interesting for those applications.
Okay, so you have a question from another expert in the field. So Hessel from Photon First Technologies, go ahead.
Hello.
Hi, can you hear me?
Yes.
Yes.
Okay. Yeah, thanks for your presentation. A very interesting new product. I was wondering whether it's possible with your product line to customize the center wavelengths of the FPGAs inside for use with different interrogators.
Yes, I think it's possible. Our expertise is between 1500 and 1600 nanometers. So for going outside these wavelengths, we would have to check. But for these, between these values, it's possible to customize this.
Right. Thanks.
Mm-hmm. Yeah. Are you looking? Yeah. Okay. Let's see. Another question from Tiago from Siemens Energy.
Hello, Cristina. Thank you for the
Hello,
presentation.
Tiago.
Really interesting. Quick question: do you already have any case study or data from field?
Not from field, no. No, we have tests done in-house. We have aging tests as well, but not on field. Still no data from real applications.
Okay.
But looking forward for that.
Yes.
I'm counting
Me
on
too.
you. I have samples.
Cool. Thank you.
Thank you.
Okay, and another one from Cliff in SILENTSYS, please. Just unmute.
Hi, Cristina. Thanks for your presentation. Question for you. Can you supply your accelerometer products in a non-metallic housing?
Meaning, I couldn't understand, a different housing?
In a different housing, yeah. So one of the constraints we're faced with the customer base is to install sensing products into a blade that are non-metallic because of the lightning protection requirements.
Okay.
So obviously all your products are in metallic housings. We'd be very interested in evaluating products that don't have that constraint.
Okay. So this one is designed, is metallic, so it's designed for other different types of structures where that material is not an issue. Yes, we can customize. It also depends on the business case that you have behind. So we are very interested in that. So if there is a market and demand, of course, that we are able to do that. We have dielectric solutions. They are for OEM customers, but we do have vibration sensors, different things for different frequencies, but dielectric vibration sensors for Siemens, for example, for monitoring power generators.
Excellent. Okay, thank you.
Okay. So a lot of interest, Cristina, for your product. Well,
Yes.
thanks again with this, and let's go to the next presentation of the session. That is given by Kristian Rode, CCO of SHUTE Sensing Solutions, and Kristian will talk about SHUTE's 1550 nanometer POF humidity sensor.
Yes, thank you, Ivan, and thank you for having me. Good afternoon. Let me just share my screen. Go to full screen here. Can you see my screen?
Yeah, all good.
Good. All right, let me just get my laser pointer as well here. Just a second. There we are. All right, we are SHUTE Sensing Solutions, and we are the polymer optical fiber sensor company. My name is Kristian Rode, as pointed out, and I'm responsible for sales and marketing here at SHUTE Sensing Solutions. I'm the first non-engineer to the company, and we are about 10 people here. So we like to call ourselves a mature startup. Initially, we are spin out from the Technical University of Denmark. And the first couple of years, we were in incubator there. And this week, we're just turning 10 years old. We are placed just north of Copenhagen here in Denmark. Our technology is a unique and patented platform technology. It's based on on polymer optical fibers, and with this we can monitor strain, humidity, and temperature, hence the name, but now also vibrations. Our technology is based on polymer optical fibers, single mode and microstructured, as you can see up here. And with a cut through of the fiber, you can see the honeycomb structure with 36 holes running in the full length of the fiber, and the middle one left out. And this is where we can capture the light. Then we use fiber bright grating technology to make sensing points. So with the laser, we from the side make a small deformation in the core of the fiber to create FPG sensing points, and we can create multiple sensing points, and they can monitor different applications on the same fiber. For that purpose, we need an interrogator, and we manufacture our own interrogator. This one is made and optimized for monitoring humidity in concrete as it dries up and cures. And this is an 850 nanometer band or range interrogator, but I'll come back to the interesting part about that in a second. But the interrogator sends out the light through the fiber, and when it hits the FPG sensing points, it creates a different wavelength coming back to the interrogator, and we're able to monitor humidity, strain, temperature, and vibrations with that. It's a well-established technology, and it's been implemented in construction, medtech, defense, and energy industries. We do everything in-house, but we can make different custom-made polymer fibers, different shapes, structures, claddings, and so on. They are mainly for medtech companies, but we also make our sensors ourselves, and we have fiber sensors for the 850 nanometer range, and now also the 1550 nanometer range. Also, for customers that need a full solution, we can create that, including software and interface, together with, of course, the interrogator. But today, and the purpose of this introduction is presenting our humidity sensor made for the 1550 nanometer range. This would assist glass fiber companies and make them able to monitor humidity using their own C-band equipment, but have a supplement of polymer fibers for monitoring humidity. And the good thing about polymer fibers is, of course, that it absorbs water molecules, and it survives 100% RH. We've tested it in different environments. For instance, from the very wet concrete as it starts to more than 5 years in the very alkaline environment of concrete. But as Cristina also mentioned, ours can, of course, also survive salt and non-corrosive environments, being of plastic. This is, of course, very interesting introduction for our part, because we can assist colleagues in the field of structural health monitoring when they need to monitor bridges, mines, tunnels, or critical joints on pipelines. They can use their own or your own interrogators and your own sensors for strain and temperature, but you can use one of the ports for a humidity sensor. And the sensor that comes with a choice of housing, it can be stainless steel like this one, where you can use your own interrogator set and your own silica patch cable to bring it out to the length that you need it to monitor in. But also in a bit newer version we've also just made is a all non-metal housing here of PEAK, and we've got a silica patch cable, and with a small rule we connect the silica with the polymer fiber inside the housing here, which makes it very easy and accessible to use for structural health monitoring and other humidity sensing applications. Just my last slide here on the relationship between humidity and the nanometer change. As you can see, it's very linear, the relationship between the two, and we have also over here tested it or characterized it in a 20 degree environment. And we have, as you can see, it takes a bit of time to stabilize, but with simple signal processing, we're able to predict quite accurately where the relative humidity value is gonna end up. So in a couple of minutes, we're able to monitor humidity on change in humidity. We've also tested it to monitor in ranges between 0.2 relative humidity. This is quite new for us. Just got the results in a couple of weeks ago, and all the way up to, of course, putting it into water, and it survives. And you just have to take it out and let it dry up a bit, and then it's back in business. And as mentioned, we've tested in different composites like concrete, but also MDO sidings, and also for monitoring humidity in oil. So if you think that this could be an interesting supplement to your C-band interrogator sensing system, then do drop me a mail or go in and contact me via our homepage, www.shute.dk. That was it. Thank you for listening in.
Okay, thank you, Kristian. Very exciting products you show. Hessel from Photon First, do you have a question?
Yeah, thanks, Kristian, for the presentation. I want to ask whether you are planning or whether these sensors are already daisy chainable. So can you connect them in series? And if yes, what is the insertion loss associated with each sensor point?
Yeah, we have been asked this already, and we are looking into the possibility of putting it into daisy chains. There's of course a bit of a coupling loss between the silica and polymer fiber, and that makes it a bit difficult, but it's something that we're working on getting that coupling loss down. We've had to test all the way down to, I think it was 1 dB, but there's also a test that shows it could be up to 2 to 3 dB.
Okay, I hope that answers your question. Okay, another question from Thiago from Siemens Energy.
Hi again. Thank you, Kristian, for the presentation. My question is related to the application and case studies that you have worked on. Have you tried to embed this sensor in any glass composite or something similar? Do you have results that you can share afterwards?
Yes, we have tried retrofitting it into carbon fiber, and that has worked. Currently, we are working together with a partner on putting it into carbon or into other fiber materials where it needs to be pressed and cured before monitoring, and these results are ongoing, but we have been able to retrofit it, yes.
Thanks. That would be very interesting if you could share afterwards some results. Yes. And sorry, second part question is, in the past I worked a bit with this similar optical fibers, FPG, and FPG is inscribed on those fibers. And one thing that I noticed is that the wavelength shift, the permanent wavelength shift with time and temperature was a little bit higher than when you compare with the silica fibers. Does this still happens with your sensors? Have you tested it?
Good question. I've got my technical expert sitting right here, Kristian Nielsen. Can you assist me on that one?
Are you referring to annealing or?
Yeah, basically, yes.
Yeah, so we bypass that issue by pre-annealing all of our sensors at a higher temperature than what's required for the operation. So we can avoid that issue.
Okay, cool. Thank you. That's it.
Okay. Question from another exciting end user. So we have Carlos here from Airbus Operations. What's your question?
Yes, thank you for your presentation. I have several questions. One is the temperature range that you have for these sensors.
Yeah, if we work with
to the capacity.
Sorry, yeah, we work with different polymers. The PMMA that is our favorite polymer to work with has a limit of about 80-90 degrees, but we are also currently testing and working, or have before worked with the other plus 100 degrees C polymers like Cionex and PC. And we have also done testing with PES, which is almost 200 degrees.
Okay. Second question is if this sensor can work multiplexed in wavelengths, for example.
Sorry, I'm not sure I understand that.
Yes, if we can use, we can put several sensors in one fiber, each one having a wavelength reference. So I don't know if it is possible or not to work with them in this condition.
It will be possible to put multiple sensing points in the same fiber.
Okay.
And with different wavelengths.
Yes, and the third question is if this sensor can be used or can be monitored with other different interrogator apart from yours. So it's possible to monitor with a classical OSA or any other, or need to be specifically with your interrogator?
Yeah, good question. Maybe I need Kristian to assist me on that one then.
Oh, it's compatible with C-band interrogators.
Okay, thank you very much. Thank you.
All right. So if no more questions, so I'll be glad to put you guys in contact also to proceed with the discussion after the meeting. And with this, so we thank Kristian and his colleague for the presentation.
Thank you.
And I introduce next speaker, who is Patrick O'Donoghue, the R&D Vibro-Acoustic and product manager at SILENTSYS. And Patrick will talk about the Slimliner, highest spectral purity laser source.
Yeah, thank you, Ivan. Can you hear me?
Yeah, welcome, Patrick.
Thanks. And can you see my screen?
Yeah, all good.
Great. Yeah, so thanks to EPIC for organizing the event. My name is Patrick O'Donoghue. I'm in research and development at SILENTSYS and also product manager of an exciting new development that I'll share with you today called the Slimliner. First, a few words about the company. So at SILENTSYS, we're specialists in ultra-low noise systems. We offer products and services in 3 key sectors: photonics, electronics, and microwave signals. We're based in Le Mans, France, or also known as Le Mans, so home of the famous 24-hour endurance race. We are a growing team of 10 people, and we have all the in-house expertise for full product development. And we're happy to have just recently celebrated our 4th anniversary since our incorporation in 2021. So the new product release I'll be presenting you today is called the Slimliner. It's the highest spectral purity laser commercially available today. It's based on a technology developed at Institut Photon, Photon with an F, in Rennes, France. And it's targeted at applications in sensing, LiDAR, metrology, and quantum tech. In terms of its general principle, so it's based on a self-adaptive photonic oscillator technology. So that's where a pump laser is locked to a cavity using stimulated Brillouin scattering, which has an extremely narrow gain bandwidth, which naturally favors a high spectral purity. If you want to learn more about this technology, you can find the scientific article shown below. In terms of its general characteristics, so the Slimliner is a shoebox-sized continuous wave laser that operates on the C-band, so between 1530 and 1565 nanometers. It has an output power just above 10 milliwatts, and it's a PM laser with a PER just above 20 dB, and it's operated using a digital touchscreen interface. And in terms of its noise spec, so we're at 5 10 to the minus 4 hertz squared per hertz frequency noise at 200 kilohertz, and lower than minus 150 dBc per hertz relative intensity noise at 1 megahertz. To show you why it's called the Slimliner, so this is a result of the phase noise, so of the beat note between two similar Slimliners measured with a Roden-Schwarz phase noise analyzer. And we can see that on a 1 megahertz span, we have over 100 dB of dynamic. So this is what we mean when we're talking about high spectral purity. This is a frequency noise power spectral density graph. So again, based on the beat note between two Slimliners. And we can see that at high frequencies, we're limited by the noise floor of the phase noise measurement. But overall, this is phase noise performance, so of a 200 terahertz laser that is comparable to the phase noise of a gigahertz oscillator. So it's really quite impressive. So to achieve this type of performance, special expertise in design and integration is required. So in particular, temperature regulation, which we have a lot of experience at SILENTSYS. So with stabilization on the order of a few minutes, and then maintaining a temperature with fluctuations of 200 microkelvin over many hours in an uncontrolled environment. Finally, I'll present a benchmarking of the frequency noise of the Slimliner compared to other available lasers. So in orange, we have a high quality fiber laser with an internal lock. And we can see that at 100 kilohertz, we have over 40 dB better phase noise performance with the Slimliner. And in blue, what we consider to be, up until now, the narrowest laser commercially available, based on a micro-ring resonator. We can see that on the full spectrum, we achieve 25 dB better performance with the Slimliner. Just before wrapping up, I'd like to announce that we recently redesigned our entire website. So feel free to visit us at silentsys.com and to get in touch to learn more about the Slimliner and about our full range of products. So thanks for your attention, and I'd be happy to answer any questions.
Okay, thank you very much, Patrick. Exciting new laser you have there. Let's see if there are any questions from the audience. And in the meantime, maybe you can mention a few words about the other products in your product line, as you said.
Yes, sure. Am I still sharing my screen? No, it ended, right?
Oh, not anymore.
Okay, perfect. Yeah, so in terms of the other products that we have, so the first product that was our main product is called the optical frequency discriminator. So it converts frequency fluctuations of an input laser beam into voltage fluctuations. So that's a useful signal that you can use to either characterize your laser or to stabilize your laser using a servo controller, which we also sell at SILENTSYS. So in terms of our electronic products, we also sell low noise voltage sources, and and for any interest and also my fellow presenters that are in sensing applications, if you're looking for low frequency noise C-band interrogator, feel free to reach out to us.
Okay. Yeah, so feel free to reach out to Patrick. Also, feel free to reach out to me if you want to get in contact with any of the speakers of the session today. I think we're now hitting the 1 hour limit of our meeting. So on your screen, you'll have a poll to vote for the feedback of our meeting. We'll appreciate feedback from you on how did you like this and also other meetings of this kind. Let me just share a few things with you. Well, first of all, yeah, this was the EPIC members product release session for you of February. And also there will be a few sessions upcoming this year, so stay tuned with us. I also recommend, I would also like to thank all the speakers today. So Łukasz, David, Cristina, Kristian, and Patrick once again for very exciting presentations and sharing the details of your products with us. So if you liked this meeting and you would like to get to know more about EPIC and our members, you're very welcome to attend our offline meeting that is dedicated to photonic integrated circuits. It will take place at one of the EPIC members' Tech that is located in Lausanne, Switzerland on March 12th and 13th, 2025. So if you have interest in integrated photonics and photonics on chips, this is the meeting for you, and this is the best meeting of the year that we offer on this topic. So please mark the date and consider joining us. So with this, I'd also like to mention that, EPIC is there for you for technology consultations, market studies, networking opportunities, mentorship, and investment opportunities. Here is the EPIC team that made all of this possible. My colleagues, let's thank them and also thank you for your attention today. And I hope to see you again in the near future. Thank you very much.
Thank you for having us.
Thank you. Bye-bye.
Łukasz, thanks, Kristian. Thanks, everyone. Great
Bye-bye. Thank
presentations
you.
today.
Bye.
So the room stays open for a few minutes more in case you want to discuss with someone. That's an open mic now.